Hello dear followers, in this video we are talking about ansys Maxwell simulation of the single phase transformer that we designed in the previous videos. We designed the transformer with the EI core with these dimensions. With having these dimensions, we are now going to simulate this transformer in ansys Maxwell that use finite element method to simulate and get the result from electromagnetic environments. Here, this is the final simulation of the transformer. It is the single phase EI core transformer that I've simulated and got the results. The transformer ratio was 1 to 10 and the current here we can see the current ratio is 1 to 10 too. Now we are going to start simulation and getting started with ansys Maxwell software. First of all, I open a new project in the ansys Maxwell software. Here, this is the steps to start and get the result from a simulation. First, we have to choose the simulation type. Let's do it. In the new versions of the ansys electronics desktop, we have HFSS, Q3D, Circuit, IcePack, Maxwell, and Simplorer. We are going to simulate ansys Maxwell, Maxwell 3D. We are going to simulate the 3D environment. So we choose the Maxwell 3D and a Maxwell 3D project will be open. Now to choose the solution type, we are going to right click on the Maxwell 3D design, go to simulation type, and we have 6 kind of simulation. 3 for magnetic environments, 3 for electric environments. We are going to simulate transformer with sinusoidal waveform. So we need to simulate transient time stepping solution type. I choose the transient option and click on the OK. So we defined and choose the simulation type 3D transient simulation. The next step is to draw the geometry. We know that we have to draw EI core and 2 windings. Now I'm going to draw the EI core first. First we click on draw option and choose draw box. We have the dimensions here, 94 for A and 56 for B and 14 for G and 28 for E. Draw a box, press the tab button on the keyboard and type the dimensions values. For X, I will type minus 47. For Y, I will type minus 35. And for Z, I will type minus 14 to simulate on the XY surface. DX, DY, and DZ, we will type 94, 56. And for DZ, we will type 28. It is the E part. It is the E part. We have to subtract some boxes to make the correct shape. It is the E part. Now we have to draw a box to make the I part. Now we have to draw 2 boxes to make the E shape from minus 33, 21, 42 for DY, and 19 for DX, and 28 for the Z part. To duplicate this box through a mirror, we'll choose through a mirror and duplicate in the mirror of the vector x. Now we just have to choose the first part and the parts that we want to subtract. Go to operations and choose subtract. Now we have E core, I core, and we have to draw windings too. For windings, we have to draw two boxes around the E part of the core. I will draw this part faster to use time for the other parts of the simulation. I draw the first box. I will draw another box to subtract from this part. Now if we choose the first box and the second box after, we can subtract these two boxes and have a shape of winding. I will change the name to low voltage. You can copy the box, edit, paste, and just change the name and change the values of the box. It's easy to change the values of the drawing instead of draw another box. Now you can see the drawing of the transformer and windings are completed. I will just change the colors. You can here change the color in the properties window. You can change the colors of the cores and color of the windings as well to have a better view. Now we draw the geometry. Now we have to assign materials. As we know, the cores of the transformer will be from the magnetic steel. To assign material, we have to right click on the choose assign material. For steel parts, I will choose steel material. We can view the relative permeability of the steel. It's a nonlinear pH curve with the conductivity, bulk conductivity of 2 million Siemens. Windings are from copper. I will choose assign material and find the copper with bulk conductivity of 58 million Siemens per meter. The first step is completed. In the next video, I will talk about other parts of the simulation.